This is a kinetic molecular theory, and this was brought about by several scientists on there. And we're just going to go over the tenets of it. The first hypothesis is that the volume of a gas is zero. Really, it's not zero. They say is small compared to the volume of the container. And what this means, this is like throwing a cup of water in the ocean. It doesn't change the volume of the ocean. So the volume of the gas just doesn't take up any space in our container. It looks like it takes up space here, but I can't make these gas molecules small enough to do that. So we just don't even worry about the volume of the gas. We'll talk about this at the end, which one of these is not going to work well. Okay, the second one is that the particles of a gas are not attracted to each other. And so, again, this is probably false. They are attracted to each other, but the attraction is so small that there is no change in their motion because of attraction. You know, if I take two cars traveling down the road, there is a gravitational force between these two, but it's so small that it's negligible and we don't have to worry about it. And so this is another one of these that for most instances at normal temperatures and pressures, it will be absolutely true. When we get outside of normal temperatures and pressures, it's not going to work so well. It will fall apart. Okay? Gas molecules, it's number 3, move in straight lines. They're in constant motion and only change direction when they collide. And that's pretty straightforward. They're just going to move in a straight line until they hit something, a wall or another gas molecule. They could collide, two gas molecules could collide, and they would fly off in different resulting directions. Maybe this one goes that way and that one goes that way. Doesn't matter. But that's what you end up with. The fourth hypothesis are that the collisions are elastic. That means no energy is lost when they collide. So elastic collisions, best way to do this is explain a very inelastic collision. If you throw mud at the wall, it sticks. That would be inelastic. And so we would say inelastic collision for mud sticking to the wall versus a super ball that you throw at the wall. The super ball keep bouncing around. Now it's not perfectly elastic because it eventually comes to a stop as it loses energy, but that's the idea. Okay, and this is an important one. The average kinetic energy is proportional, that's a proportional sign, to the temperature in Kelvin. And so what this results with this proposal is that first result is if we increase the temperature, we expect the kinetic energy to increase. Makes sense. And B, if we decrease the temperature, we expect the kinetic energy to decrease. That's straightforward. Well, it gets a little more complicated because the kinetic energy is equal to 1/2 mv squared. Okay? And so what happens when we do A, if we increase the temperature, that means we increase the kinetic energy, which means that the velocity right here, the velocity has to increase. If the kinetic energy increases over here, we can't change the mass of a molecule, so the velocity has to increase. And so what we find is the temperature is going to increase. An increase in temperature increases the velocity, and that will have a lot of effects like changing the pressure. It will increase the energy and of collisions and frequency of collisions. Frequency means how often they happen. So those are the 5 kinetic molecular theory hypotheses. Okay, so which ones are wrong? The first one, the volume of the gas is not 0, and we will find this out when the volume of the container gets small and the pressure gets high. Okay, so this falls apart at, so number 1 falls apart at small volumes and high pressure. Number 2, particles of gas are not attracted to each other. That fails at low temperature. At extremely low temperatures, what happens is they start moving very slow. And so they start moving so slow that the small attraction force can take over. It becomes more important. How do we know this? Well, we know gas will condense into a liquid, and that can only happen if there are attraction forces between the molecules. Okay? Gas molecules move in straight lines. That's always constant. Collisions are elastic. It's not quite true, but we don't worry about that. And the average kinetic energy is generally always true. These 3 are always more or less true. True for us. Okay? That's the kinetic molecular theory. In a nutshell, we will refer to that in the next outcome on there.